All right, so in this video, we're going to go through the sample question number 23 from the Society of Actuaries ExamP list of sample questions. So the question reads, an actuary studied the likelihood that different types of drivers would be involved in at least one collision during any 1 year period, right? And here are the results of the study given in this table. Now, what they're giving us is the type of driver, so teen, young adult, midlife, senior, the percentage of all drivers that, that we're looking at. So of all the drivers we're looking at, 8% of them are teens, 16% are young adults, right? And then the probability of at least one collision. And that one's important to look at because what that is, probability of at least one collision, is the probability of at least one collision given that we're in this category of type of driver. So this 0.15 refers to the probability of at least one collision given that we're looking at a teen driver. Okay, so that's important. This column is conditional probability. So here, given that a driver has been involved in at least one collision in the past year, we need to calculate the probability that the driver is a young adult driver. So this problem, super easy, virtually just, it's a Bayes theorem problem, and they give us a chart with kind of what we want. So let's say type of driver is D, whereas, I'm gonna get a different color, kind of orange. All right, so type of driver is D. The percentage of all drivers, that's the probability of being that type of driver. And the probability of a collision, right? So that's the probability of being in a collision given that you're that specific type of driver, right? And the thing it's asking us is, given that we're in a collision, so what's the probability of being a young adult? So the probability of being a YA driver given we're in a collision. So one thing that tells me right away this is a Bayes theorem problem, this is kind of a big indicator, is when we know the answer to this, probability of collision given being young adult, and we're asked to compute this, right? That kind of thing tells me, all right, Bayes theorem. And again, I don't currently have a video on Bayes theorem. If you want one, ask in the description, and I'll make it happen. But it'd be too much to kind of explain the whole thing. So using the equation, so the probability that a driver is a young adult given that this person's in a collision is equal to the probability of being young adult and being in a collision over the probability of being in a collision. Now, we don't have either of these pieces of information, but we can get them. So the probability of being a young adult and being in a collision is actually equal to the probability of being in a collision given that you're a young adult multiplied by the probability of being a young adult. And this is going to be divided by the probability of being in a collision. Now, the way you have to figure this is we have to sum all the probabilities of being in a collision. All right, so what are all the different ways of being in a collision? Well, that's going to be, you could be in a, so I'm going to extend this because I have a feeling it's going to be a larger denominator. You could be in a collision given that you're a teen, so probability of collision given teen, times the probability of being a teen. And this is kind of just what Bayes theorem is, plus the probability of a collision given you're a young adult multiplied by the probability that you're a young adult plus the probability of being in a collision given you're in midlife times the probability of being in midlife plus the probability of being in a collision given you're a senior multiplied by the probability that you are a senior. And we can use the table to fill in all these pieces of information and just algebraically compute this, right? It's just going to end up being a fraction. So probability collision given young adults, that's going to be equal to 0.08, and that can be taken from the chart. multiplied by the probability of being a young adult, so that's 0.16, over the probability of, being a teen and getting in a collision, so that's going to be 0.15 times 0.08 plus the probability of being in a collision given you're a young adult, so that's probability of being a young adult, that's 0.08 multiplied by 0.16, and then following, logically following, that would be 0.04 multiplied by 0.45, so collision given midlife times probability of being in midlife, and then that's multiplied by 0.05 times 0.31, so probability of being in a collision given you're a senior times the probability of being a senior. Now, I'm just going to plug this into the calculator, right, and get my answer. So just give me one moment. I don't have these worked out beforehand because I think it's important to see you watch me solve these in real time the way I would actually think through a full question. All right, so it's the numerator divided by 0.15 times 0.08 plus 0.08 times 0.16 plus 0.04 times 0.45 plus 0.05 times 0.31. And our answer is approximately 0.219554031. That's the answer the calculator is giving out. And since we're rounding to 2 decimal places in our answer choices, that is going to be 0.22 or 22%. Answer choice. All right. So I hope that made this problem a little more clear for anybody having trouble. And what can we learn from this problem? So occasionally, if you've seen some of my other stuff, I've always talked about making a diagram or a chart, if not, once you have the information, but sometimes they give that to you. So when they give it to you, it's very important to be able to identify what each column properly represents, like symbolically almost. So once you figure out in this particular question, you just need to know Bayes' theorem. Plugging in that formula, figuring out that, the probability of young adult and being in a collision is collision given young adult times probability of being young adult. And then the, total probability of, having a collision would be the sum of all these different values. Okay? And that's pretty much it. It's mainly just, you'll see if you're kind of doing these in a row, a lot of Bayes' theorem problems in a row that should stress how important this particular topic is. If there are any extra questions or something that you think I should clarify, leave that in the comments. I'll answer questions to the best of my abilities. If this video helps you out, hit the like button, subscribe. That definitely helps me out. And other than that, good luck, guys.